Hello everyone, my name is James, and today I will be going over question 3A from the 2023 Set 1 of the AP Physics C Electricity and Magnetism exam. So, first, of course, we are going to need to read question 3. So, the circuit shown consists of a battery of EMF, resistors 1 and 2 with resistance R, capacitors 1 and 2 with capacitances C and 2C respectively, and a switch. The switch is initially open and both capacitors are uncharged. Okay, so now that we have read that, we're going to read 3A. So at time t is equal to 0, the switch is closed to position A. So write, but do not solve, a differential equation that can be used to determine the charge Q on the positive plate of capacitor 1 as a function of time after the switch is closed to position A. Express your answer in terms of EMF, resistance, C, Q, T, and fundamental constants as appropriate. So there are some important things to note from this question. Now, the first thing is we only need to write the differential equation. So write, but do not solve. So we don't need to solve it. We just need to write the equation. Now, secondly, it has to have time in some way or form. So we have the diagram right above, so we are going to use this as a reference. When the switch is closed to position A charge will flow through the two resistors before reaching the capacitor. Now, it is very important to realize that there are two resistors. So, according to Kirchhoff's voltage law, the sum of the voltage difference around any closed loop in a circuit must be 0. So in this case, the voltage drop across the resistors plus the voltage drop across the capacitor must be equal to the voltage of the battery. So think about this like Halloween. And bear with me for this explanation, please, because I'm going to need a bit of leeway. So, across the night, you will be giving candy to those who come across your house. And if things go right, your remaining candy by the end of the night should be 0. So, in this analogy, the length of the night is the circuit, and the kids who come for candy are resistors, capacitors, inductors, or anything that will take voltage from the battery. So we have already established that this problem deals with Kirchhoff's voltage law. So we should be thinking about different ways that voltage can be written. To help us visualize these possible ways that it can be written, I will draw a pyramid to the right that represent the equations found in Ohm's law. So we have V up top, and then I and R. And if you want to know how to use this pyramid, just cover the variable that you want to solve for and then do the rest. So cover I if you're looking for I, and I is equal to V over R. So that's how you use that. So now that we have the equation of the voltage of the resistors plus the voltage of the capacitor equals the voltage of the battery, we can substitute for the voltages. For the voltage of the resistors, we will substitute in I times R over 2 from Ohm's law. And remember, it is R over 2 because we have two resistors. Now we have I times R over 2 plus the voltage of the capacitor. But remember that we need this equation to have time in it. So we're going to express this as Q over C equals the voltage of the battery. So to have time in here, we are going to need to use the differentiable equation of I is equal to dq over dt. So using this will allow us to change the equation to dq over dt times r over 2 plus Q over C equals the voltage of the battery. So because we have a dq, we will substitute Q over C in for the voltage for the capacitor as we've done here, and that leaves us all with Q over C. So we don't have to go any further now. This is a differentiable equation written. We don't have to solve it. So this is all that we need to do. Now, some common mistakes that students can make would be not accounting for the fact that the charge is going across two resistors, which would just be dq over dt over R, or times R. So many students may just try to treat it as if it were one resistor, so be sure to take note of any time charge is going through more than one resistor or capacitor. Additionally, some students may forget to bring time into the equation, like the problem said. So be sure to do everything that the question asks you to do. So to recap what we used in this problem, we made use of Kirchhoff's voltage law, Ohm's law, which was over here, and the equation for the definition of capacitance, which was that there. So be sure that you have a good understanding of the diagrams and what is asked before you try to jump into solving the question. Now, if you don't, you will most likely skip parts that were asked and probably miss points on AP tests. In the description, there will be links to all of the full FRQ tests that were released for Physics 1, Physics C Mechanics, and Physics C E&M from 2023. If you have any questions or need additional information, please feel free to leave comments and I will answer them. Thank you for watching.